Hi everybody. Today we're going to go through the notes on section 34.1, which starts on page 485. We're going to begin talking about matrices. And so the first time we use anything with matrices, we're just going to go through this kind of slow. To set up a matrix, how do you organize your matrix? How do you identify your matrix? How do you give it a name? Things like that. So today we're just going to go over some super basics. They're going to use an example of two girls trying to make cutting boards. That's what that picture is, all the different styles of cutting boards. And they get different hardwoods. So style 1 says uses 4 strips of walnut. I'll fill this in. 3 strips of maple goes across, and 2 strips of cherry. Style 2 uses 5 strips of maple and 4 strips of cherry, so we can assume no walnut. And then style 3 uses, I'm right here, uses 8 strips of walnut, 5 of maple, so then no cherry. So then they start talking about a matrix. So that's obviously just a table where everything is labeled, very easy to fill in. A matrix, of course, we want to strip everything down, and we don't really want to have all of those words. We just really want the numbers. So each of these numbers inside the table here are called elements or entries. And so if we take this and sort of write this with matrix notation, a matrix notation uses these kind of squared off brackets. And so we'll just put this information in here, 408, 355, and going down, of course, is 240. Now the way this works is that this is row 1, going down, this is row 2, and this is row 3. So you do the rows go down. The columns go across. There's column 1, column 2, column 3. Because to name your matrix, you would name it rows by columns. And you would use, of course, the numbers. That's what the dimensions are. So like, for example, we would go down, then across. So this one is, being that it's the same dimensions makes it pretty easy. This one is a 3 by 3. And we'll go through a few more so you have some other examples. But it goes down, then across. So that's what they're talking about with the dimensions here of matrix S. So a matrix gets a capital letter, and I kind of wrote all over it, but you name a matrix with a capital letter. The calculator will do the same thing. And so the matrix S would be, you go down and then across. So it is rows by columns. And so this is a 3 by 3. So when you see this little s, that means use matrix S, and then your subscript 31, this is row 3, column 1. So that's what this means. So if we go down 3, so 3, 1, 2, 3, and over 1, we're right there. So we go down 3 into the first one. So the element or the number in the matrix that corresponds with position 3, 1 is 8. So this obviously goes through this kind of slowly, which is all right. So now it's telling us that we're using row by column information. And so matrix S was, I'm going to write this down so we can keep track of it, sorry. Matrix S, in the directions again, said matrix S was a style by wood. So down were the styles, across were the types of wood. That's what we saw. So now in number 5, they got a contract for cutting boards. 6 cutting boards, style 1, 5 for style 2, 3 for style 3. Shonda had a contract for cutting boards in style 1, 5 in style 2, and 4 in style 3. We want to write a matrix N, and it tells you person by style. This is important. That means the people go down. So we have Monique, and Chandra. And then we want the styles to go across. Style 1, 2, 3. I'm just trying to use the notation they used. And then, of course, our notation. So, again, if we look back at it, Monique had 6 for style 1, 5 for style 2, and 3 for style 3. Chandra had 4 for style 1, 5 for style 2, and 4 for style 3. So the dimensions of matrix N, remember we go down then across, so this would be a 2 by 3 matrix. Now they've given us the next matrix, matrix D, and this is a person by style for the month of December. And so now we want to find out the total number that they had for their orders for November and December. So we're going to write matrix T for total. And we have Monique and Chandra. And then we have style 1, 2, and 3. So Monique had to make a total of 5 and 6, so a total of 11 style 1s. Style 2, she had to do 3 and 5, so that's 8. Style 3 is 4 and 3, so that's 7. So what we're adding is the same position. So if we think about this, Chandra now, if we think about this as being the lower left-hand corner, and this about being the lower left-hand corner, you add those together. In the bottom in the middle, 5 and 4. So that's a 9. And then the final one is 4 plus 2, which is 6. And this is how you add matrices together. It makes sense when we did it that way because we had all the numbers there, we had the people and the style, we were able to sort of line up what each thing meant. But when you add these, the elements, so we'll say the dimensions of both matrices must match. So you have to have the exact same parts in order to add 2 matrices together, or 3 or 4. So now we're going to just add some together. These don't have any meaning. It says, if possible, and it'll always say if possible because it's not always possible. If possible, find the sum or difference of the following matrices. And if it's not possible, explain why. So this first one is a 2 by 2, down then across. The second one is also a 2 by 2. So they have the exact same dimensions. So when you add these together, please create a new matrix and then add the positions. Upper left, 16. Upper right, 12. Lower left, 0 plus negative 8. And lower right is a 4. So when you add them, they stay in the same spot as the parts that you added. You don't move them around. You don't do anything to them. This matrix in part B is a 2 by 3. And the second matrix is a 2 by 2. So this is not possible. The dimensions are not the same. So that's what they mean by don't just say you can't do it, explain why. Now, for subtracting, up to you. You can go through and change all the signs in the second matrix, or you can just think about subtracting. It's totally up to you. If you do decide to change the signs, then you always add the opposite. Sometimes it gets a little bit hard to keep track of everything. You're more than welcome to use your calculator if you can't keep track, but I'm going to go through and change all the signs to the opposite, because the definition of subtracting is to add the opposite. Now these do have the same, because this is a 3 by 2, and so is this one. So it is possible to add these together. So 8 plus 4, negative 6 plus a negative 7, 3 plus a negative 5, 6 plus a negative 6. A 0 is allowed, so don't think you can't have a 0, because you can. 9 plus negative 4 is 5, and 10 plus 3 is 13. And so that is how you would add those two matrices together. In order to add or subtract, they have to have the same dimensions. We just went through that. If they don't, then you cannot add them. Now, when you think about an identity, if you go all the way back to Algebra 1, an identity means you don't change the identity of the number. So in addition, they're explaining it to you here that means adding 0. We want to know what is the dimensions and what are the elements of matrix O. Well, they told you we have an m by n matrix. So matrix O has dimensions m by n. And then all of the elements, each one, are all 0. So if you're thinking about, well, how would I not change the number? You'd have to make an entire matrix of zeros. You can't just add 1 0. Your dimensions still have to match. Even though it's a 0, they still have to match. Now, an additive inverse is a fancy way of saying opposite. And so to take the opposite, you would just have to, again, you'd have to make sure that every entry in the matrix is the opposite of the original one. We'll call, I guess we're supposed to call it matrix A. Now, in order to multiply, we don't really call it multiplying. We call it a scalar. It's like a vector. It looks like distributive property. It is essentially distributive property. So they're asking us to multiply 4 times s. And if you recall, vector s was this, 16, 12, 8, 0. Sorry, that's not vector s. That's something else. So this will be vector s. It's hard to keep track of when it's so many pages behind. Vector s is this one, 4, 4, 0, 8, 3, 5, 5, and 2, 4, 0. So if we take 4 times vector s, that means we're just going to take 4 times each element inside there. So this is 16, 0, 32, and then again 4 is what we're multiplying by, so 12, 20, 20, 8, 16, 0. Please make sure that you leave it, all of the elements in the same original position, that you use the correct brackets, and that you give these matrices names if you're asked to. So if you don't have your book, you need to freeze this or something. This is your assignment right here on this page, 488. We're doing all of this. Ooh, sorry. 14 through 16 on page 488. Thanks for watching. Make sure you have your assignment ready for tomorrow.